Transforming linear functions. Transforming linear functions, it's very similar to just the transformations we talked about earlier last week. To do a horizontal shift or a horizontal translation of h units, f of x is going to change to f of x minus h. This is the general formula, x minus h. To shift it to the right, h has to be positive. To shift it to the left, it has to be negative. When I actually put a number in there, if it's positive, it's going to, if I put in shifting it to the right, 7. This would actually say f of x minus 7. It has to be a minus there. So if we have a vertical shift of k units, and we want to shift this blue graph, or this blue function, to the red function, we take the actual function f of x, and we add or subtract a number to it. If k is positive, the graph moves up. If it's negative, the function moves down. To do the reflection of a function over the y-axis, we're going to change the x value of the function. So to reflect this blue line over the x-axis, over the y-axis, we make the x negative. Sort of like we did in the last section. If we wanted to reflect something over the y, we change the x. To have a reflection over the x-axis. In the last section, if we wanted to reflect something over the x vertically, you had to change the y. But instead of y, we have a function. So if you want to reflect over the x, you need to change the sign of the entire function. We're going to find the g of x that's the indicated transformation of x. We're going to write the rule for it. We know that f of x equals x minus 2, just a function you're given. We want to take that function and translate it horizontally to the right 3 units. So what's happening here? What transformation is occurring? Horizontal translation. So we just flip. Horizontal translation. What do I do for a horizontal translation? It has to be x minus h. So to do this, we're going to have g of x is f of x minus 3. Some of you are wondering why it's minus 3. If you want to move it to the right, it needs to be a minus 3. The formula itself, or actually the function itself, you have x minus h. This has to be there. So it says just 3. If you had to move it to the left, what would you have written? X plus 3, y plus 3. The two negatives become a positive. You have to think opposite of what you want to write. Because what you're really doing is you're taking this and you're finding out when it's equal to 0. If you're trying to find out when it equals to 0, you add 3 over, x equals 3. It should cross the x-axis at 3. Now we have to actually go in wherever we see an x. We're going to replace it with x minus 3. So here's the function. X really meant x minus 3, and I still have the negative 2. It's right here. Negative 2 still from the function. Instead of writing x minus 2, x really means now x minus 3. So I replaced the 1x with x minus 3. Now I need to simplify. I only have the 1x, right? What's a negative 3 and a negative 2? Negative 5. So your answer is x minus 5. Now I'm going to show you in a calculator.
So you get rid of the X, you get rid of the F like that, and you get X times 3.
I replace the x here with this. If I go y equals, type the original one, x minus 2. And the second one, I'm going to write this, x minus 5. And I'll make this line darker. There's the first graph. There's the second graph. Has it been moved or shifted or translated 2 or 3 units to the right? 1, 2, 3. It's been moved to the right 3. Questions on this problem? This is a translation to the right. So I'm taking the function, and I'm going to move it to x minus 2. Remember, it has to be x minus h. X minus, it has to move 2. So when I substitute in, this is going to become this. G of x is going to be 3 times, instead of being x, you put x minus 2. The plus 1 is still there. When I came around and looked, a few of you had the parentheses around the 3x minus 2. You put the 3 with the x with the 2. It's 3 times whatever your x value is. Now I'm going to distribute. 3 times x is 3x. What's 3 times negative 2? Negative 6. Still have the plus 1 on the outside. Can I simplify any further? The negative 6 and 1 is negative 5. G of x is 3x minus 5. Good. You're not always given the function. Sometimes you're given a data set. And it's saying up top that you have the function of x. Here, we want to take a reflection over the x-axis. So first thing we need to do is create a function. When we're talking about functions, we need to find a slope and an intercept. To find my slope, I am going, it's y equals mx plus b. So you did remember something. Now, if I look here between my y values, how is it changing? It moves 1 here, it moves 1 here. What should the next one do? Move 1. Every time it's going to move 1 x value. Now I need to look at, where would it be if I started my graph? Well, the start is a 0. You want your x to be 0. It starts at 2. So my original function is x plus 2. If this would have been a 3 here, it would have been 3x plus 2. It's not, so I'm not going to put it there. We good? Now, right, there's really, it's 1x there. So that's 1x, but we don't write the 1. 2 comes from the starting point. X is 0. If we had a graph, it crosses right here. That's the start of the graph. All right, that's where the 2 comes from. You'd have to find the 0. We'll get into all the refreshing of going through all the equations. Now we need to find g of x. G of x,
What's the difference from fx and g of x?
a name. There is no difference between f of x, g of x, h of x, q of x, t of x. They're just labels
Why we gotta find g of x?
because we want to find the new function. We're taking one function and translating it or changing it into another function. If we just called them y's, I would have y equals this, y equals this, y equals this, y equals this. Can you tell each one from one another? No. That's why we're using the functions of going f of x, g of x, h of x, t of x, so we know which one we're talking about. We're reflecting over the x-axis. So I go through here, reflecting over the x. What happens when I reflect over the x? Everything changes. Everything changes. If it was a reflection over the y, it would only be the x value that changes. Because it's a reflection over the x, everything is going to change. So when I simplify this, g of x equals negative x minus 2. The first one is x plus 2. X plus 2. The other one is negative x minus 2. Whoops. Nothing graphed. If nothing graphs, remember last one I zoomed in. I'm just going to do zoom 6, back to standard. What I was doing is I was telling the calculator to look over to your left and it needed to look to your right. Here's the first one. There's the second one. If you think about reflecting over the x, did this flip down? Did this flip down? It's like I took the entire graph and flipped it over the x. I did it correctly. Use your graphing calculators to check your work. Now, for stretches and compressions, they're like changing the slope of a linear function. If a line becomes steeper, it has been stretched vertically, or it could also have been called compressed horizontally. If a line becomes flatter or more horizontal, it has been compressed vertically or stretched horizontally. If you think of a rubber band, if I take a rubber band and I stretch it horizontally, what happens vertically? It gets smaller. It gets compressed vertically. If I stretch it vertically, what happens? Horizontally, it gets compressed. So when you do one thing, it affects the other. We will later on talk about things that will actually stretch it entirely out, but that we're not there yet. This is just like our old one. Horizontally affects the x's. So if I want to affect by a factor of b, we're going to multiply just the x by a factor of b. If we want to vertically affect something, we're going to multiply the entire function by a number. Remember that if the b is greater than 1, it stretches. If it's between 0 and 1, it compresses. For vertical, if it's greater than 1, it stretches vertically. 0 to 1, it stretches horizontally.